Foundation Lecture Number 1, Introduction of Foundations. A construction project starts with performing tests, including soil testing, and preparing a geotechnical lab report. Design office will use soil properties to design the structure, including the substructure, and then after that, the construction can start. So let's start with the definition of foundation. Foundation is defined as the engineered interface between the earth and the structure it supports. The purpose of foundation is to transmit the structural loads to the soil supporting a structure in a fashion consistent with the purpose of the structure. So, the foundation or substructure should be environmentally friendly, economical, safe, and it should limit movements, including settlement, to acceptable values. So we use load tracing to follow different types of load that we have on our structure, dead load and live load, throughout our superstructure, and calculate what is the total load transferred to substructure. Then we also have bearing capacity of soil. So we have load applied from superstructure. We have bearing capacity, and we can design our substructure to avoid bearing capacity failure and to limit settlement. Different types of materials are used in the construction of foundation. The most common type of material is concrete, which can be plain concrete, reinforced concrete, pre-stressed or post-tension concrete. Steel, wood, and composite are also used as a construction material for foundation, but again, the main type of material used for the construction of foundation is concrete. We have two different types of foundation. If the ground is firm ground, it has the required engineering properties, relatively high bearing capacity, and we have a smaller structure, then we can use a shallow foundation. But for the cases where we have a larger structure or the soil beneath the structure is a weak material and it doesn't have the required engineering properties, then deep foundations are used. Basically, whenever shallow foundation doesn't work, we need to use a deep foundation, which is basically using piles to transfer the load from a structure to the lower layer where we have the required engineering properties. This will also help with controlling settlements in this structure. Let's look at different examples of shallow foundation. So this is a spread footing which can support columns. We have concentrated or point load from building columns. Then in this detail that is provided in this slide, the load is coming from a steel column, then a base plate which connects or transfer the load to concrete pedestal, and then we have concrete footing. So we have the load applied from superstructure, and here we have the bearing capacity. Bearing capacity or bearing resistance of soil. And if you remember, load applied divided by area of foundation or footing should be equal or less than allowable bearing capacity to avoid bearing capacity failure. We can actually use this to find the required minimum width for our substructure. Again, these are details of a spread footing, which is an example of a shallow foundation, and concrete has relatively high compressive strength and low tensile strength. So that's why under fractional load it starts to crack at the bottom of the slab or beam. We see cracks appearing. So that's why rebars are placed at the bottom of the beam or a slab, because a steel has a higher tensile strength, so it can provide or increase tensile strength of that element. Another example of a shallow foundation is when we have load-bearing walls. So now we have a distributed load on the bearing wall. Then we have concrete foundation wall, and the load is transferred to the concrete footing. And again, we have soil resistant or bearing resistance of soil. Load applied, resistance, and we can use these two to calculate the minimum required width for our foundation. The third example is basically when we have a spread footing, individual columns or footings that are too close to each other and they overlap. And also another reason to use mat or raft foundation is to limit the amount of differential settlement between adjacent areas. And it's usually used when we have weak soil. Okay. So now we have these columns that are point loads or individual loads, but then the load is distributed.
Don't worry, we'll be back.
Uniformly using the mat or round foundation. Now let's look at different examples of deep foundation. Based on the construction method, we have two different types of piles. We have driven piles, where we have precast concrete section. So it's precast concrete. Or we have different types of steel section. Then using an impact hammer or a vibration hammer, these piles are driven into the soil. The size can be from 6 inches to 8 feet in diameter and from 10 feet to 200 feet in length. The second type is when basically a hole is made in the soil, rebars are placed, and then we pour concrete. So there are two different construction methods. For piles, we have driven piles and bored piles. So again, it's important that we have a system to uniformly distribute the load. For example, if we have a concentrated load from column, pile cap is used to uniformly distribute the load between different piles. Or if we have a bearing wall and a distributed load on the wall, a grade beam, a concrete grade beam, can be used to uniformly distribute the load between the piles or piers. This is an example of driven pile. As you can see, we have steel sections driven into the soil using an equipment. This is also a video that shows driven piles. So this is precast concrete, and then we also have steel sections. There are two different types of equipments. This one is an example of impact hammer, which uses impact, and it can be noisy, but it drives the pile into the soil. There are also, and this is an example of vibratory equipment, which uses vibration to push the pile or drive the pile into the soil. The second example is bored piles, where we have drilled shafts, rebars are placed, and then concrete is also placed in there. So again, first we have drilling shafts. Then also the caisson can be placed. Rebars are placed, and then concrete is poured in there. Okay, so then they place the rebar inside. And then finally add concrete. So this is the second construction method, which is drilled shaft. When the use of piles are not applicable due to different restrictions, we can replace piles with micropiles, which are high capacity, a small diameter. They're drilled and grouted in place. They usually, for micropiles, we need a small drilling equipment, so it works better where there is limitation, there is limited access, restricted headroom, or in the urbanized area. It has a lower impact on existing surrounding structure. And the last example is using a different material. So instead of concrete, we can use aggregate for the construction of aggregate piers. It can be more environmental friendly since we're not using cement and concrete. And aggregate piers are columns of compacted stone installed in groups in poor soil to increase bearing pressure and also mitigate settlement.
7 to 30 feet. Layers of aggregate are then introduced into the cavity in thin lifts of about 1 foot in thickness. A proprietary and patented beveled tamper rams each layer of aggregate using vertical impact ramming energy. This pre-stresses and pre-strains the aggregate at the bottom of the cavity while forming a bottom bulb. Then, thin lifts are incrementally placed and rammed until the pier is constructed. The result is superior strength and stiffness.
Okay, so the whole purpose of soil study, studying properties of soil, preparing a geotech lab report is to avoid failure. There are different types of failure. What you see in this slide are the failures that can happen in retaining walls or in shallow foundations. Overstressing the soil below the footing can cause bearing capacity failure. When moment equilibrium is not maintained, we can have overturning. And when horizontal force equilibrium is not maintained, we can have a sliding. And when vertical force equilibrium is not maintained, we can actually have settlement. Same thing for deep foundation. We can have vertical bearing capacity failure, horizontal bearing capacity failure, or settlement. So we need to study properties of soil to avoid different types of failure in our structure.